In this lesson, what we'll do is we'll take a look at waves in general. We'll do some vocabulary review, some properties, and then we'll also look at a little bit of mathematics. Wave itself is just a propagation of energy. When you watch a wave in motion here, really the wave is the thing that's actually traveling, in this case, from the left of the screen to the right of the screen. But if you watch any single particle, that particle is actually just traveling, in this case, up and down. It's really not going anywhere, right? So we'll take a picture of this, and we'll paste it in here so we can take a look at it. And so we can identify now parts of the wave that we're looking at. Again, notice that the one little single green dot here, although the wave was actually traveling forward, that single particle was just oscillating up and down. Because that's perpendicular, this would be something called a transverse wave. That's where the wave particles are vibrating in a direction that's perpendicular, or 90 degrees, to the direction of the wave itself. The other type of wave that you might see is something called a longitudinal wave. This might be a wave that you would do on like a slinky. That's where the wave particles themselves would oscillate in the same direction as the wave itself. There's some other parts and pieces to the wave that you should know. One is, if this wave were kind of turned off or shut down, all those little dots would be along this center line. That's called the equilibrium point. Once you have that equilibrium kind of established, you can also take a look at where's the furthest a particle actually vibrates away from equilibrium. In that case, it might be something like this area here. And that distance measured from equilibrium to the maximum, or from equilibrium to the minimum, is something called the amplitude of the wave. The amplitude is always measured in units of distance, centimeters, meters, feet, that kind of thing. The last piece of the wave that you really should know about is something called the wavelength. The wavelength is a measure of how long one cycle of the wave actually is. And that's also another unit of distance. So if you were to look for a complete cycle here, what we might do is find out where here's the wave at the very peak, and then where is a full cycle? Well, there we are again at the peak here. So this distance from here to here would be something called the wavelength. The symbol that we use is lambda. It looks like an upside down Y, and that denotes wavelength. Again, this would be a measure in distance, so either centimeters, feet, meters, that kind of thing. That's the basic terminology for waves. The next thing that you would probably need to do is to be able to do some calculations with waves. There's really only one model that you've used in your physics class, and that is that the speed of a wave is equal to the wavelength of the wave times the frequency. Remember, the frequency is how often a cycle repeats itself. That would be like 5 times a second or 24 times a minute, that kind of thing. If you write this out in symbols, you'd have V, which is speed, is equal to the wavelength, which is lambda, times the frequency, which is just F. So an example might be something like, if you had a wave that had a wavelength of 300 meters, and its frequency was maybe 10 times a second, or 10 hertz, that would let you actually calculate what the speed of this wave happened to be. In this case, it's just 300 times 10, or 3,000. And that would be meters times hertz. Remember that hertz is just 1 over seconds. So that would actually give us 3,000 meters every second.